Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So for today's show, I'm joined by Tomi Ristimaki, who is the CEO of a really interesting company called Kempower. Thanks for joining me today, Tomi. And if we could get started just by finding out a little bit more about you and your background. How did you get to be doing what you're doing now?
Yeah, hello, Ryan. Nice to be here today. And looking at my background, I will not start from the day one, but let's start from the career-wise, from the beginning. So I actually joined a company doing industrial motor control with power electronics back in late 90s. And actually started working with industrial energy saving and this clean tech industry with power electronics. And actually, it felt pretty good to actually be working something that good to the world when you're saving electrical energy. And then actually in 2010-11 timeframe, got a phone call from a friend of a friend, and who was founding a startup for e-mobility, looking at electric powertrains for heavy vehicles and hybrid systems, motors, inverters, control systems. That was really interesting move, and spent actually about 7 to 8 years doing that and trying to convince people that electrification is the thing that will happen every next year that you are talking with the people. And let's say the market in e-mobility was completely different than it is today. And back in 2009, then I got another call, again on about charging industry and looking at the pure electrification. And that was also the time that I understood that the electric vehicle thing, what I have been talking about more than 10 years, is actually going to happen now in a large scale. And this kind of a key to actually opening the market is also involves a lot on having charging infrastructure manufactured that fits to the market. And that was the kick in, and then the rest of the story is what we see today.
And just so people, the frame of reference, so you're from Finland, right?
Yeah, correct. And this is Finland is kind of the home of industrial power electronics when it comes to the beginning of the industry, and a lot of background and companies working on that.
Well, it's always surprising that a relatively small company, relatively small country, could, there's such a high density of really great engineers and engineering businesses and particularly around electronics and motors. Some very famous companies have come out of Finland. Is it something they put in your breakfast cereal, or?
I think it's a country of engineers. So I think we excel in technology, but we suck in marketing. So we probably might have the best system in the world, but we forget to mention that. So that's a kind of maybe the sin of the Finns, to actually have something great and not to be able to. We are now learning it more to be let's say more world-conquering mode in marketing as well. But it's typically that the Finn might have the perfect solution, and then you just wait for the customers to actually pick it up without even mentioning it to anybody. So maybe that's kind of the past. But I think it's something that in a small country, people have to focus on something. And in Finland, it has been tech, and especially industrial tech and power electronics in the past.
Yeah, it's and a wonderful country as well. The only drawback appears to be the neighbours, but
yeah, that's another discussion. Yes, correct. That also changes the country a bit to having let's say different kind of neighbours on the east for the whole history of the country. Yeah.
So now the business that you're leading now, Kempower, could you give us a background story to Kempower and where that company came from?
Yes, as a Kempower in the current format, let's say the 100% fast charging company is actually a spin-off on an old family business, which was concentrating in power engineering, power electronics since the 1940s. So this is our, let's say, parent company's main interest has been on the welding industry. But it's about inverters, and they were the first company to make a DC power supply inverter in the 70s. And this is kind of the heritage of manufacturing industry and the power electronics background of the company gave a good boost actually to concentrate. Kempower as a charging company was founded in 2018, or on paper 2017, but the actual, let's say, R&D started in 2018. But in the category of companies working now in e-mobility, we are kind of belonging to the group that is a spin-off from steady companies and having like a new direction with the technology that was developed with years and years and background and manufacturing background. So that helps a lot when scaling up the company, when you have kind of the heritage of the group.
And is it a Finnish group or is it outside of Finland?
Yeah, it's a Finnish group called Kempi Group. And it's a family Kempi, and it's a person, Martti Kempi, who started manufacturing milk carts somewhere in the 40s, and he needed equipment to actually get them together. And he decided, I will make my own welding machines because the other machines are not good enough. So that was basically, and then the product ended up being power engineering and welding. And there was other things done like, let's say, making power supplies for the particle accelerator in CERN with the brand Kempower already in the 90s. But let's say, in the current format in Kempower is a purely charging company, and in that format and more like a standalone part of the Kempi Group, it was founded in 2008.
So your product line now in Kempower is the infrastructure charging hardware. Is that how you would describe it?
We call it the fast charging. So basically, when it's fast charging and it's high power charging, this is something that people cannot have at home. So it's definitely this public side, heavier vehicles. And we have been growing now faster than the industry and probably the world's fastest growing DC fast charger manufacturer. Of course, when we look at where we are active today, we started from the Nordics. And today we already gained the kind of like the market leader position in the Nordics and now expanding in Europe and looking at the other markets as well. So I think the idea what we had and how to change the charging industry from the product point of view and the solution point of view was good because we can see now the customers really appreciating our solution.
So these are the large public chargers that you might get in a charging park, service area kind of thing. And you mentioned commercial vehicles, so I guess that it means supplying directly to truck operating companies and bus operating companies and that sort of.
Yes. And also bus OEMs, truck OEMs, and basically when we come into this early market, it's also the case that the first truck sites are sold, that the trucks and the chargers are sold by the same companies. It's also things what happen in the early market. But yes, very important target for us is the operators of the commercial vehicles because they have their private charging sites. And how we see also this, when you separate the home charging, what you do for personal cars, this AC charging, which is like a special sockets in a box, to the DC fast charging, which is high power. For large commercial vehicles, even the so-called home charging is DC charging. And that's why it's for us DC charger manufacturers is really important to work with the commercial vehicles.
Okay, and that's so because there's some interesting things that I think we'll probably get on to talking about with the commercial vehicle side with standards and what's happening there. But if we just talk on the, it's such a big topic still. The charging infrastructure, we sort of see it almost on a weekly basis. Some kind of story about lack of capacity or a new network, or I think the the other day, Daimler made a big announcement about putting a big investment into infrastructure for charging. Obviously, Tesla has their own network already, and there are lots of these private networks. So what one brand or another around. So those kind of those network operators for the public infrastructure, would that be your kind of typical customer for the?
Yeah, that's quite typical. And you said actually a key word before you called charging parks. I could call it charging plazas, or you could call it charging hubs, or whatever name you use. But this is also how we see the market, where you can charge many vehicles, because you understand that there will not be a single vehicle, single charger situation when the market really starts happening. So I think our approach is to actually think about fleets that you have many electric vehicles coming to similar sites, when a lot of the other charger manufacturers are thinking like a one charger, one car situation when they are thinking about their product portfolio. So we see the market actually that high percentage of the vehicles is electric, and how do you answer that question? That's not anymore a single charger, single car, because the worst thing that can happen to EV driver when you go to these charging sites, that there is a single charger or there's two chargers and they are occupied when you arrive. And you don't know how long they will be there. So these kind of charging plazas should actually offer more plugs, more connectivity to the cars when you are there. That's basically differentiated also Kempower, how we do our solution.
Really feels like the market's gone from a situation where there were lots of charging infrastructure and no cars to use it, and now a lot of cars and not enough infrastructure again. So it's kind of like a wave, and maybe does it seem like that from your side?
Yeah, it exactly sees, and it's also maybe the biggest reason for the growth we have been seeing in Kempower, that we are growing faster than the rest of the charging market, that we kind of saw the situation from the beginning in a point that you have a lot of vehicles charging in the same locations, and people are more comfortable on going somewhere that that you can actually get the car charged and not to wait. And in the early times, you had a single car, and then somebody installed a single charger. That was a party. Now I can charge my car. But once there is 10 cars in the same site wanting to have a lunch at the same gas station, and then the situation changes, and then the solution must actually answer this question, and how do you connect all the cars, and so that you can do something else during the time when car is, let's say, taking the power.
What is it about your solution that facilitates that? Because it just sort of stepping back slightly into the numbers. I mean, even if that charger park was 10 150 kilowatt chargers, which I know, obviously now it's 350 kilowatts with the sort of ultra charging standard, but let's say 10 150 kilowatt chargers, that's a 1.5 megawatt connection or power consumption required if all 10 are being used at the same time. If it's 10 350s, that's 3.5, and that the context, that's massive.
That's massive, and that's exactly the problem with this kind of a standalone chargers, where you don't have the possibilities to move the power dynamically between the charging outputs. And what we do differently, that we actually separate the charging hardware and then the charging points, and we can move the power between the points flexibly, what we call the dynamics. So nice terms in UK used electron juggling chargers, that you are actually moving the actual charging capacity from vehicle to other, because there is many cars who are charging. When we look at personal cars, they ask for a lot of power in a certain point of the charging curve, but not throughout the whole time. And also the people who charge very fast, they might leave the car there for, let's say, half an hour too long. And when you have the situation that the capacity is fixed and somebody's occupying the spot, there is no way to charge more. The only way you can do, you have a massive grid connection, massive amount of, like you said, 10 350 kilowatt chargers or 10 150 kilowatt chargers. We might get a better output of having, let's say, that we install 800 kilowatt of centralized power and then 10 charging outputs, and then move the power between those flexibly as the cars need it. So you can live with a smaller grid connection, but you can actually get more output because it works like the cars work, and it works like the people work, and not having overcapacity.
Okay, yeah, I can see. Interesting. So, and upstream. So I know some companies are looking at. Actually, I've seen this in a couple of different ways recently, but between the kind of charging infrastructure and the grid connection, some people are introducing things like battery packs to kind of buffer that, so you can run an even smaller grid. Do you have that kind of system?
Yeah, we have been working in that kind of project. It's normally that somebody else has delivered the batteries that our partner. We have those, especially in Norway, you have certain sites where we are working, or it might be even movable solution that you can move it to other site, that you have a fast charging infra with battery and chargers you drop into the field and just connect small power. Last summer we had a system in France which was only powered by solar and batteries, with barely no grid connection at all.
Ah, wow. Okay. So I was just about to ask: is that the renewables, like localized renewables? Is that a thing?
That is, but of course, when you know something about solar panels, to having significant power compared to the power the EVs need, the solar field must be huge, and that normally includes also the battery, because you might be producing the power when the cars are not there. So this is, of course, we have certain truck sites, for example, in southern Sweden, where there's massive solar field and battery, and then more than 50 high power chargers for trucks in the same location. But of course, you cannot produce all the power with the solar, because that's local production. But many of these CPOs companies, the bigger companies might have even their own wind power generation. Like we have good examples in Finland, companies who have invested in wind power, using that wind power actually to sell. And end users using EVs, they are normally quite environmentally friendly, so they want to prefer the sites which have also the clean power.
Yeah, and I guess particularly in our current climate of unpredictable energy costs, let's say, it gives you some certainty and stability in terms of your supply costs.
Yeah, true. And looking at a lot of these things affecting the energy prices today is affecting also the lack of oil coming from our eastern neighbor to the market. And people are thinking that they should solve it by limiting amount of electric vehicles used, when the problem is oil. So you start using more oil to limit somehow the problem happening because of lack of oil. That doesn't sound very clever to me, but it's
yeah, actually, the smart option is more electric vehicles, more renewable power, and
but to have a more efficient energy system in total. Because when you look at the moving, you know this as well as I do, because we come a little bit from the same industry, that actually an electric vehicle is more efficient in total in the use of energy. So
yeah, a lot more efficient, and it's especially if you could direct wire some electricity into the charging system as well. On the batteries, before we kind of leave that, do you see that as being effectively a solution that is going to be more widely applied to kind of answer the grid connection problem, or do you think it's sort of still maybe just a niche option, and you will mainly have the installation of a large grid connection in a charging park, or do you see the trend be going to smaller grid connections and maybe a battery pack?
Very good question, and I think the answer is, I used to live in Germany, and they always say "jein," which means yes and no in the same word. So this is I think it's very area wise. In normally when look at like our home country Finland, we have very stable grids and almost oversized grids for everywhere, because everybody's having an electric sauna at home, and that's already oversized. Because and then basically main in Scandinavia, when you look at most of the houses are electrically heated, so you already have quite oversized grid for the normal. And people are also changing the heating systems at home to heat pumps and things. So the grid has capacity. But when we go to, let's say, UK, Central Europe, you might have, let's say, not so oversized grid compared to the consumption, and then you have the challenge. And I think in the short term, there will be seen more sites with batteries. But in the end, when we are increasing the electrification, I think the countries must look at the investments in the grids as well, because it's not a, let's say, completely future-proof solution if you want to run the country with a grid built in the 60s without investing when the power consumption is going the other way around, because we see the electrification moving in other industries as well. If you look at how things are done, because the total energy efficiency in the end is the key actually for the climate change improvement. And you have to look at the, let's say, the energy in total, not just electrical energy or whatever energy, because we have to save energy. And it's a way to produce energy and move it very efficiently is electricity. So this is, in my eyes, is a key for this transformation. But in certain places, you will need more investment to the grid. But I think in the short term, we will see sites with batteries. And it's an interesting question that will the electric vehicle batteries have a second life as grid batteries? Because once they get old, there is still a lot of lifetime left in the batteries, because when people don't accept them to be used in the electrical vehicle anymore, there's still 80% capacity left or 70% capacity left that they could be used as, let's say, buffers for the grid. This is something we don't see yet.
Yeah, well, a good friend of mine, Matthew Lumsden, who I did a podcast with ages ago, but probably do another one. He runs a business which is doing exactly that. So second life batteries, connected energy, so that they are doing some really good work in that space.
And I think that they are doing really extremely good work, because people are thinking that electric vehicle batteries get old in 5 years, which is not true. I think it's more than 10 years normal lifetimes, and then you could still use them another 10 years in the grid or 15 years. So we don't see the masses of electric batteries yet there, because there hasn't been electric vehicles for 10 years. But within time frame, there will be a lot of batteries.
It's true, actually. That's been, I think, a challenge that some people have had, is that the batteries are not coming for the second life because they're lasting. Because they last a lot longer than people presume in the first place. So, yeah. Well, one other application that I don't know if you've, but I keep thinking, well, okay, so the charging parks are these very sort of large power consumers, like unusually, typically in the locations that they're in. And if we're putting a battery system in for the grid connection, but one of the things about, I'm pretty sure with vehicle charging, there'll be patterns. So, it'll be unusual to have people charging at 2 a.m., for example, just because the cars aren't on the road. So when people are traveling, it'll be when the charging systems are used. And I'd wondered if there's a sort of a possibility that those battery systems could start to play like a financial role in kind of arbitrage of energy almost. So if the charge station operator can take energy off the grid in an off-peak time when the energy is really cheap because there's no demand, and maybe we're actually having to pay to turn off generation capacity, so it's sort of costing us money as the energy consumer to not generate energy. So actually, if we put it into something, that's a whole other topic, complex sort of how the grid works. But anyway, from a charger operator point of view, if you could take some power and then when it's really cheap and put it in a battery and then sell it when it's not so.
man. And basically the fast charging energy sold from a fast charger is the best priced electricity you can sell. So that makes all the sense in the world, I think, on that point of view. But anyway, even if you have battery, you have still some connection. You have energy limitation or you have grid limitation. And I still see a strong point on being able to deliver charging solutions that use the available capacity in the most efficient way and distribute the energy in the most efficient way to vehicles, that you can maximize the outputs and maximize also the income for charge point operators, because you can have more transactions, more cars connected. So it is exactly the point that you have to get the car connected to get the energy, and then the time is a question of money and investment, and this is.
So we'll leave the batteries. I know that it's just sort of interesting.
It is, and the increased spot prices in certain time of the day have definitely increased the discussions around batteries now. And we don't see is the electricity price so volatile anymore in the, let's say, next 10 years. But today, especially in every country suffering something energy shortages, then the spot price is varying so much that this is a prime time for the battery guys to be talking to the customers, because you can see the benefits immediately.
Well, yeah, definitely. The really unusual thing at the moment is we've got this big problem with very high energy costs. So electricity is very expensive because of the cost of gas, but also one of the other problems that we have, because we the way the grid is designed, we've got more renewable power coming on, and it's costing us more and more money to reduce the power output from the wind power system when it's not being consumed. So doing something to sort of fill that gap and use that, the wind doesn't blow during peak electricity time all the time, and there's all these surpluses in the system, which just mopping those up, there's a huge opportunity from an environmental perspective and a cost perspective and a system efficiency.
I think if we go a little bit off the topic, it's renewable energy actually brings the challenge that you have to have certain kind of energy storages, whatever they are, if they are batteries, or like people in Germany are pumping the water back to reservoirs to make hydropower, doing a better times, or you will have a local production of hydrogen and hydrogen power plants, whatever the form of energy. But energy storages probably are increasing because of use of renewables, because you are not so much, let's say, you cannot direct production times directly to the needs. So some kind of energy storages are needed. If they are hydropower plants, or if they are hydrogen generation areas, or they are batteries, but definitely you need some kind of buffers.
Yeah, and it's a great opportunity with the charging parks to put those in. So on your systems, your technology, I think from what I've seen, the approach, the kind of hardware approach that Kempower uses is a little bit different to how I think a lot of people visualize a charging park, because we see this big unit with a cable and we plug into it, and I think most people think that is where it starts and ends, and that's it. But you're from a hardware perspective, your systems are really quite sophisticated. So could you sort of explain that a little bit, and the kind of the system level? What does it look like? What's the hardware going into a charging park?
So we have the centralized power unit, and that's basically the charger in a traditional sense. So you have all the electronics of a charger is separated to another module. And this is also to answer the grid limitations, that you size that unit based on the grid limitation. Then you choose how many charging points you need to have that you are dividing the power to. And then distributing the power for the whole parking lot from this one location, and not basically needing to have every time the same power electronics for every parking lot done again and again and again. It's costly. And the other one, it was like exactly like you said, if you want to have 150 kilowatt charger, you need 1.5 megawatt connection. When you have, let's say, 600 kilowatt charger with 6 outputs, everybody capable of making 150 kilowatt. Normally, when we look at also from our cloud system, you rarely actually meet the limit of the charger, because the cars are charging with different powers, and you have different kind of cars. And people are also thinking that there's only these high-end, very expensive cars which charge the highest power coming up. I think the middle class and the small cars will be entering the market even with lower powers, because it's about the cost, and it's about affording a car. And I think first comers is the luxury cars, and then we see also the middle class, and charging power and the battery size will cost money. So it's natural to believe that there will be variations in cars kind of a wider variation in the future.
Yeah, sure. We still have our little Renault with a small battery, and it's great. Does the job.
And also thinking my daughter is turning 18, so what kind of a car I will buy? Not probably buy a Tesla or something like.
She deserves a Taycan.
Yeah, I know that. And you need to have the 400 kilowatt charging power when you're driving inside the city or school. So it's not really. It probably will be Renault Zoe or Fiat 500e, which is a reasonable car for inside city traveling. So. It's a completely different needs in different classes. So
yeah. So this the central power unit is where you take the AC from the grid and you're converting that into DC. So that's your, and then you're distributing actually the DC is what you've got, a DC kind of mini grid on the charging park, and then the things that people see, the like the sort of the fuel pumps, if you like, that's kind of just a box with a cable then that's with some software and controls and interfacing.
Difference also to other solutions, you might have that you have a DC grid and then you have the converter to make a controlled DC on the charger. We actually make the controlled DC outputs already in a centralized power unit. So that's doing everything, and then you don't need to have the big units anymore in the parking lots, and reusing this control devices, making the charging control from a centralized location. So in commercial vehicle, this relates normally to overall lower investment cost because you can more levelly distribute the power between the sites. And in the public charging points for private cars, it actually means that you can redirect more capacity to the cars and get the cars moving faster, because these are the two drivers in two industries which are a little bit different.
Yeah, and it's a good, because one of the other things that I see quite a lot is chargers that are damaged, that people have driven into or people have vandalized or whatever. And in your system, actually, the thing that's the public are touching is quite a simple, relatively simple unit. And if someone drives into it and smashes it, actually the expensive stuff is protected somewhere away.
And even that would be destroyed like completely. You have still 1/8 of the system only down, or 1/6 of the, depending on the system size. But basically, single failure only leads partial failure, and not as a complete stop.
One of the things that sort of baffled me, or I can see as being like a really difficult challenge, and it's maybe my background's in kind of hardware development, and the AC to DC and the kind of control, I get all that, and it's all really difficult, interesting, making that efficient and high performance, all the power electronics, it's like really cool. But and a big but in the charging systems that are going into public applications in Europe, you've got all these sort of requirements now for like different ways to pay, and how hard has it been to implement that kind of the front end, the interface between the charging system and the general public, the user?
Yeah, I think it's a one thing what we thought about in the beginning, that how to make it easy as possible, and to make our system accommodate all the possible payment methods. But then it's up to the people who actually sell the electricity also to be able to do that. So this is lack of suitable, let's say, credit card terminals was a beginning. People say that a lot of devices have credit card terminals, but in real life, if you start looking at the market, they are not very suitable for the use. Now it's starting to pick up, and it's easier. And it's especially these people protecting things like the rule that you have to have the PIN code in every fifth purchase, and lack of having terminals with the proper PIN code, having IP classes that can actually withstand the weather outside has been a bit challenging. But I think the many ways of payments and things is something that early markets always have. Preferences have been different. Do you have the RFID tags, or do you have mobile phone apps, or you have people call the Tesla system, which is actually a closed system that you cannot use with other cars because they give more information to their own chargers than they give others. And people about thinking about is the ID of the car personal information that you can actually store or not. So these kind of privacy things are interesting, because I think we are doing auto charge functions with commercial vehicles, which is a business and not a private people, that you can already recognize the cars. But then the plug and charge is a lot more difficult, because that's protecting the identity of people. And it takes a while when you start doing with this kind of a privacy protection things, and you need to. So it's been interesting, I would say, and challenging as well, because there's so many things to think of when we look at is the car ID actually something like a personal identification data. And I think the plug and charge is answering to that, but then there is not a single plug and charge. Some car brands have their own way of doing that, and then some cars are using the ISO standard. And
is that already a requirement, or is that coming as a sort of blanket requirement that the public infrastructure in Europe has to be plug and charge compatible?
No, I think they are going the other way. I think when we are looking at the European, they are talking about credit cards.
Okay. So turn up and pay. Yeah.
Because if you have a plug and charge, you still need to register as a customer to the service provider, because somebody needs to know it's your car. And I think when we're looking at the governments looking at it, they want to have a payment system that the people don't need to register to. If it's cash payments, like we have seen happening in some countries, we have been delivering that some people want to pay the electricity in cash. That is actually happening still. Then you have and they want to pay the electricity at the desk of the gas station like they are used to. And you have the people who prefer credit cards, people who would like to have only Apple payments or Google payments or any other kind of, let's say, mobile payment options. So it's a wide variation today, but I think what the governments are looking for is that just like in the selling fuel, that people should not be required to register to a company to be able to buy, that there should be a method for anonymous buying. But then everybody is implementing that in a different way, so that's where the confusion comes now, because somebody might have SMS payments or somebody has credit card payments. And I think when the market matures, it will come normally. The ones who have a good way of working will be the winners, and those charging stations who have something bad will be empty. But today, when we have let's say, we would need more charging stations, everything must be used, and this kind of a market development doesn't happen.
Yeah. Yeah. Well, so one last question on the sort of general public passenger vehicle stuff. That recent announcement I mentioned earlier from Daimler about them putting their own network in, and I know, so some of the OEMs have kind of said things like that, which basically haven't meant that they will be investing in hardware, because it's like a virtual network, and they're going to kind of sit over the back of one or two of the larger private charge point operating systems. But the Daimler intent appears to be they're going to actually put their own hardware in strategic locations where they think that there's a need for that. And I've seen two very sort of polar opposite responses to that. You know, people go, yeah, great, this is the right thing to do, and people going, well, what's the point? You know, that surely they should just put the investment into public accessible stuff rather than their own thing. What's your view on that in terms of deploying that network? Do you think it's the right thing for Daimler to do now, or are they too late?
It's good thing that people are investing in charging infrastructure. That's generally a good statement for us in DC charging business. But I think not all the car brands need their own networks. Especially they must be that the requirement should be that they should then support all the car types. And it's whoever is building the charging network. I think it's also the response what Tesla did early on. That still the car manufacturers, the traditional OEMs are thinking, should they do it in the same way? And we have, like you said, we have seen this announcement many times in the world. And I think car manufacturers are starting to understand that the lack of charging infra might be let's say, limiting their sales in the future. So they are also coming into the game. But I don't know if every car brand needs their own dedicated system. So
I reckon they must have done a survey of like buyers of their products that have then gone over to Tesla. What were your main reasons for purchasing a non Daimler product? And it's because I do hear so many times people that one of the main reasons, especially people buying the more kind of premium car, maybe using it more for business purposes and things like that, is charging it. The sort of appeal of Tesla will live with a lot of other issues with those vehicles, but the security of that charging network is one of the big draws to that brand. I could imagine someone at Daimler's gone, well, we're never going to be able to beat them unless we can counter that argument.
And it's now happening that whoever, let's say, invest in charging infrastructure will have the same limitation to grid connection points and how fast you can build, and it is the same market. So I don't see exactly the point that every car manufacturer must build their own. But I think what Tesla did clever is that they are thinking the market in the same way as Kempower. So of course I think they are clever, but having they have a similar idea of having the centralized power and then have a certain outputs and have more cars charging in the same locations, which I think is a key for larger fleets. And this creates the convenience. And then you have, of course, your closed network possibility of, let's say, recognizing the cars. Because when you buy a Tesla, you have a Tesla account and then you're already recognized and you have the payment there. But the others could do it in the same way, but then you have several service providers and things. And I think in the future, there will be even more service providers. So I think the key will be basically having a convenient way of working.
Yeah, convenience, I think, and people value convenience so much. We pay premiums all the time for stuff that's convenient. You just look at buying stuff off Amazon. It's, it's convenient, if nothing else. So
we can say convenience or laziness, but it's anything which requires less effort will somehow sell in the future and have the security and peace of mind. These are what the people are willing to invest in.
Well, that's a big one too. Like not having your credit card scammed is a big, it's a security, peace of mind, knowing the stuff's going to work, because that's a lot of a problem with the very sort of variable, even some of the bigger network. I mean, actually in the UK, probably the biggest network operators are the worst in terms of reliability for the, turning up and stuff not working. So the OEM being able to own that experience, I think it sort of keeps the customer in their kind of in their zone, and it's a revenue thing as well. In the if you own the charge network and the distribution of the charge, it's quite easy for you to give an incentive like 10,000 miles of free charging. I own that, so I give it away and it's at cost price. But if I'm having to pay someone else to give you that 10,000 miles of free charge, that's going to cost me a lot more money to do as an incentive. But then once that's over, I can make, albeit fairly tight revenue stream, but a profitable revenue stream from selling you power in the future. And actually that's the long-term revenue potential for this car that's going to be out in the field for 15, 20 years is massive.
And we are seeing now already electric vehicle reaching to amounts that the charging business starts making sense already in the short term. It's not anymore like a 10-year investment that you can start earning money after 10 years. It's in the best locations. If you look at, for example, Norway, where you have a really high number of EVs compared to capita, the charging stations are paying themselves back in less than 2 years or 1 year, depending on the site. So this is starting to get quite interesting for infrastructure investors and things. That this is a fast way if you look at how the infrastructure pays itself back.
Yeah, well, I would think even a conventional fossil fuel petrol station, gas station, the investment cost of that wouldn't pay back in such a short time. And think by the time you've buried all the tanks in the ground and built, and all the permitting and stuff. So it's a really good point that investment case is is starting to get there. That's good. And obviously the money will follow the money in terms of then adding capacity.
Yeah. Of course, there is the only thing that the charging stations with this kind of a normal marketplace will pop up in the place where you have a lot of EVs. And of course, then the governments need to make sure that you have some subsidies for the areas where are scarcely populated, that you can actually have the whole ecosystem working. So this is also the key. But I think when people are looking at that, they give like funding for charging stations, they should make a focus on this kind of a network coverage. Because I think in the highly populated areas, charging stations will pop up based on just the ability to sell electricity to EV drivers.
Yeah, there's an interesting dynamic there with highly populated areas which tend to lack off-street parking and sort of personal, because obviously the best way to charge your EV, if you can, with the driveway and things, is to use your own power at home and do it slowly overnight. But
it's not always possible in the large cities. I'm thinking about London cannot support everybody of having a home charging, so it will have a more than focus on the public charging and public charging locations and these charging parks or charging plazas wherever they are. So
the interesting, so like destination charging in, so obviously you've got sort of people traveling for work, and you can kind of map those corridors out and things. But then you've got these anomalies like tourist attractions. So the area that I live in is fairly rural, but we have the old the Hadrian's Wall, the Roman things, and it's popular with tourists and stuff. But there's not much charging infrastructure because it's fairly rural, and there aren't many people live here. But there are people who want to visit, who might be driving an EV. So there's sort of the planning that, it's complicated, and if you can't answer that, all of those different use cases, it does stop people from being able to enjoy their vehicle, which is and the travel that they need to do and want to do. So
yeah, I'm a heavy believer in the destination charging, that you should have a possibility basically wherever you visit that you can connect your car and get the power. And then you don't need to, new EV drivers are thinking that they have to go somewhere to tank the car. So I believe more in this destination charging, that you have the ability when you're going shopping or you're going to see a tourist attraction, that you can actually use that time and charge the car. And we are not there yet. I definitely say that. But I think also this government funding are thinking about the highway sites, which is really important. But I think in the end, the destination charging will be very, very important.
Yeah, well, one of the things I think that will drive it, like you said earlier about the investment case, if you're a site that attracts a lot of people, at the moment, your car parking facilities are just a cost to your business. So maintaining the car park and providing those parking spaces for people is a cost to the business. It doesn't earn you any money at all. It's just a necessary evil. But if you can provide destination charging, all of a sudden, that becomes a revenue generating opportunity where you can, make some money from that asset that you have.
And if the attractions is on a way to somewhere else, and you place a cafeteria or restaurant on top of that, so you have a perfect place for the business actually start earning money with the car park, which, like you said, it's an extra cost today for these kind of.
Yeah, it's very different to the concept of setting up like you said, the kind of concept of like we do with the petrol station. The petrol station has to be separate because of the storage of fuel and the safety, and and you couldn't have a petrol pump on every parking spot in the supermarket car park. Although I'm sure someone's probably thought of doing that in the past, but it wouldn't work. But you could have electric charging points on every place in the car park or the cinema or the whatever shopping mall.
And planning actually the charging for the time of the visit. So this is also, is it DC, is it AC charging, whatever makes sense for the average visit time of the people who are spending there. And then basically having always the fast and slow side by side that you can choose, and or you can choose from the system what power you want to take and pay for that. Because I think the people are still thinking that you should pay only for the energy. Actually, what you are paying for the time spent. So you could have like flexible paying methods. You take only 10 kilowatts or you take 150 kilowatt with a completely different price. But the device could be the same. That's at least what we could do today. So
well, no, I mean, actually, so plugging your technology or your product, but your approach to that, how you design your systems, actually that allows much more. You could have fast charging points distributed because they're not. The reason why you wouldn't do that with a conventional system is because the fast charging units are A, very big and ugly, but B, really expensive because they've got all the electronics. But if it was just a vend point and that maybe you could have it so the electronics, the central unit served a lot more vend points because you knew they weren't going to be used all that often. It would be possible to do that. That's.
Yeah, and it's of course, I don't know how the end users understand it, but we could today already offer that you could actually have I'm buying only with low power because I know I will be 5 hours, that we could offer the means actually charging less for that the capacity is available for the others. But this is kind of, people get confused today because we are still in the world of this kind of one charger per car situation and this kind of flexible system, but there is a lot of possibilities that can offer the convenience and can offer also the cost savings. If you're not using the capacity, you would pay less, and you are not occupying the whole system like with the standalone chargers. So this is something where I see a lot of development. We did a lot of work for that. I think with our backend system in the behind that it could actually offer all these pricing options and availability options and even booking systems. But these are, because you are not alone there, because we are not a charge point operator. We are not the ones selling them. So we offer the means today, but let's see how the market takes.
Yeah, it's really interesting. So I'm really conscious of the time, so we're running out of it. But I did want to ask you about commercial vehicles because that's another sort of area that I'm really interested in and a huge, in terms of electrification. Your past, like mine, we were doing heavy vehicles and off-highway machines and all that kind of thing. So with commercial vehicles, there's a few sort of interesting challenges. Running, I always say to people, running one electric truck out of a depot as kind of a trial is fine. Like, it's quite easy. You can do that almost anywhere. But if you want to turn 10 trucks or 100 trucks electric, actually that starts to get really super challenging from a charging point of view, a grid point of view, and all of that, because of the size of batteries. So an electric truck is equivalent to at least 2, if not 3 or 4 or 5 cars. So the batteries are much bigger, and we tend to want to use them, on a high sort of utilization. So we don't want to leave them charging for a long time. So what in the commercial vehicle side, we've got these like new standards coming for megawatt scale chargers. What do you see happening there? What's the sort of, are you deploying parks in sort of, I don't know, truck depots and bus depots and things? Do you see megawatt charging coming in? Is there an grid infrastructure in the, like, public infrastructure, let's say, for trucks coming? Like, what's happening on the commercial vehicle side?
I think there are several fields as well, and we have markets like in private cars. We talk about home charging. For trucks, this means these overnight depots wherever the vehicles are spending the time. If it's a bus or truck, then you have some place where they are, let's say, resting, and that should be used, and that's called, I think, the somehow destination charging in a way. And I think we should use every opportunity for the trucks also to be charged whenever they are unloading or loading. They should be actually plugged in. So these are the logistics centers to actually use all the possible time. And I think then we come into the megawatt charging, which is this en route for long distance. Interesting development. I think the chargers are ready, but the connection points are still under development. And what will be the standard? Will we go over 1,000 volts, or where are we standing there? So I think the main goal, how I see the market, that especially with long distance, that the truck should be charged in these 45-minute breaks, which are legally required for truck drivers to take, and to be as close to that But I think we will see the development of services around that, because when the truck driver approaches the site, he's booking the system already beforehand. We have that kind of project already in Sweden, where the truck driver can book the place already before he arrives. And these are kind of this is a business way of thinking, because time is money in logistics, and when you have business involved, then people are willing to also spend a little bit more money than somebody spending 5 minutes less in their holiday trip or business trip with a personal car. So these are a little bit different approach. It's a tool of business, and powers will increase because the battery sizes will increase. How much? Then it remains to be seen. Will it be 3 megawatts, or will it be 1 megawatt or 800 kilowatts? But not all charging for trucks will be megawatt charging. There's a lot of this overnight. You have the logistics center opportunity charging spots. So for us in DC fast charging manufacturing, we see this as a huge opportunity, because many of these heavy vehicles, even the flow charging might be 50 kilowatt or 150 kilowatt DC charging, which is completely different than in personal cars. Home charging is AC charging, is out of the scope of Kempower, but for us, the trucks, we have then the 100% of the interest on this market. So.
Well, yeah, because you see, so a lot of the truck OEMs that are coming to market now with battery electric distribution trucks, the onboard charger is like normally about 22 kilowatts, where a typical passenger car would be 7 kilowatts or less. So, but the 22 kilowatt charger is a really expensive bit of hardware that they're fitting to the truck, and they're doing that. You know, if you're doing that to every truck, it's not all that efficient. Or
you might want to do actually 3 of them in every truck, to have 3 plugs, or something to actually get some reasonable power. Even the 22 kilowatt for heavy truck or even lighter truck is quite low power.
Well, this is it. It's low power, but it's still, because it's on board, so it's got to be really compact and light, and but it's going to be several kilos still, and maybe a couple of €1,000. It's an expensive bit of hardware. I think as the commercial vehicle market matures, what we'll see is they will get rid of those, maybe go to a low power onboard or even no onboard charger, or something just for emergency purposes. And if they've got a more mature system where they know they've definitely got 50 kilowatts at every loading dock they're going to see, and at the rest stops and such like, you don't need that, and it's quite a big saving that you could make on a truck by truck basis by getting rid of that bit of hardware, or significantly reducing it.
But if we step into that way, actually the onboard charger in personal car has even higher percentage of the total cost of a vehicle. So there's also long-term discussions. People are thinking should you have a portable DC chargers also for that, for small power, to get rid of these onboard chargers, because they are creating a cost in every vehicle. But as a trend, I see maybe this personal car charging, you don't see anymore many 22 kilowatts. Maybe Renault Zoe being the last one standing, and it's going to 11 or it's going less. Is it a single phase or 2 phase? But yeah. Yeah,
the Zoe, it's kind of a different case, isn't it, with the Chameleon, I think, still. So it uses other bits of hardware on the vehicle. It's kind of elegant in one way, but not elegant in another way, in terms of how they're getting the power. But you can't do vehicle to grid either with with that sort of system. So
with a cheap AC charger, because actually if you would like to do vehicle to grid with the AC charger, that would, let's say, multiply the price of the AC charger then on board, because it should be two-way power and that actually changes. Then the vehicle to grid coming to the market actually enhances everything to DC. It might even change the home charging to DC if you want to have your car working as a battery at home.
Yeah, so the pilot trials that have happened, I spoke to someone who worked for one of the companies that was running a big pilot trial in the UK for vehicle to grid, and using the Nissan Leaf, because that's the only car that supports it today with CHAdeMO. But the box it was a DC wall charger, small one, albeit, but that was the the sort of the thing they had to develop to implement that vehicle to grid trial to work with the Leaf was a suitable DC home charger.
Yeah, because it's Chademo who works with that, and then yeah.
So you're right. There's another really good opportunity coming.
Yeah, that's an interesting opportunity, but then of course that the price point is a little bit different than in public systems. But I see it expanding to, because if you look at vehicle to grid, that's exactly the places where the cars stay for a long time. What are those places? It's workplaces, homes, airports, the ones where you use today AC chargers. So this is kind of interesting how that turns out and how widely V2G comes to the market with the cars, because it takes time to develop this in the car as well.
Yeah, there's a whole topic in itself there, isn't there? Which I'm really quite passionate about that. With going to, we're actually about to have a battery system installed in the house, but it's tiny, compared to the batteries we've got sitting on the driveway in the car. So
I left the battery system from home out because my solar inverter delivery time was so long, so I had to choose a model which doesn't have a battery input. But that's but that's an interesting point, and it's my wife called it that it's actually an expensive hobby, not really energy saving, but it's
yeah. That's probably well, yeah. It's an interesting one. So commercial vehicles, there's a lot going on, megawatts, and just to wrap up, I know you've been talking recently about what's happening with Kempower and your plans and stuff. So just want to tell us a bit about what you're excited about, what's coming, what's happening in the future for you.
I think what we have been really how we are seen in the market, like we are making a difference with the DC charging, that the demand is increasing, and that's why we are also looking at different markets and different expansions now. Of course, we are looking heavily on the US. It's more or less a new market for electric vehicles still today, and I think it's moving really fast. It's growing faster than anything in the world in the form of electric vehicles in numbers today. But of course, it's very much in the beginning, and we are let's say looking at the end of this year to actually have a manufacturing facility in US in some form. So it's really a big effort for us and a main project for this year. But we also yesterday told that we are looking at expanding in Europe for the manufacturing capacity, because we see the demand is increasing. And one of the big things what has changed in the demand is also this commercial vehicle, what we already discussed. The trucks coming to the market is, especially for us DC fast charger manufacturers, this changes the game a bit, so increases the market size quite a lot.
We'll on that, we'll bring it to a close. So thank you for taking the time out to join me today. I wish you all the best with Kempower. It's fascinating kind of following you and seeing what you're doing. To people listening, as usual, I'll put show notes in and with links to the company and to Tomi and some of the other things that we've spoken about. So scroll down and have a look at the show notes. Had a couple of people asking me how do they find them. In some of the podcast apps, you need to click to sort of open the description of the show notes, and you'll find it down there. But that's all for today. And thanks, Tomi. Thanks again for joining me.
Thank you, Ryan, for interesting discussion. I think we could have talked longer for the old time's sake as well. But yeah, thanks.
Well, in the not too distant future, somewhere, I'm sure we will we'll see each other, and I think a beer is called for.
Yeah, exactly. Good.